We want to show that if an is a positive sequence, every member is positive. Show that lim_sup of n times 1 plus an plus 1 over an minus 1 is at least 1. So again, we recall the meaning of lim_sup. So we know that not every time we have a convergent sequence. So sometimes the sequence may be divergent, but it definitely have limit points, like a convergent subsequence, such as this sequence. 2 limit points, 1 and -1, 2 convergent subsequences. Or maybe we find a subsequence that converges to positive infinity or negative infinity. So we put all those limit points into a set, and we take the lim_sup. We take the supremum. We call it lim_sup of that sequence. And vice versa, if we take the infimum, then it's lim_inf. So how do we know that it can be proven that the lim_sup is actually the biggest limit point? So how do we know that the biggest limit point is of this sequence is bigger than equal to 1? How do we know that? Well, first, of course, we prove by contradiction. Let's assume that if it is less than 1, what's going to happen? All right, so an 1 plus an plus 1 minus 1. Right. So what happens is that, what kind of contradiction can we get? Say here is 1, there is a. Let's say lim_sup. Okay, let's say lim_sup is less than 1, so lim denoted as a. Now, could the I'm thinking, is it a finite number or negative infinity? Since it cannot be positive infinity, so could it be negative infinity? So let's say if it's negative infinity, I say it's impossible. If the lim_sup, if the greatest limit point is negative infinity, which means all the other limit points are all negative infinity. So the sequence itself is convergent to negative infinity. So, but we're given the sequence is positive, so that's impossible. So lim_sup has to be a finite number. Right, so finite numbers say it's less than 1. Right, what's going to happen? So here's my claim. The claim is that given any epsilon bigger than 0, for a plus epsilon to the right-hand side of a plus epsilon, there is at most finitely many members of this sequence. Right? If to the right-hand side of this point, there are infinitely many members of that sequence, what's going to happen is that, according to Bolzano-Weierstrass theorem, we can at least find a convergent subsequence whose limit is definitely bigger than this point, or even positive infinity. But we already know that this point is the greatest limit point out of all the limit points of the convergent subsequences. Right? So, in other words, to say that to the right-hand side of this point there is at most finitely many members is the same as to say to the left-hand side of this point there is a capital N, fixed capital N, dependent on epsilon, so that for as long as little n is bigger than capital N, all of the members will fall to the left-hand side of this point. All of them will live in here instead of there. So there I only have finitely many of them. right? As n is big enough, they will all live in here. So in other words, from this point onwards, the n times an 1 plus an plus 1 minus 1 is going to be less than a plus epsilon. Right? Now I can just let a plus epsilon equal to 1, right? So epsilon is just some positive number, right? Any positive number is okay. So I let epsilon equal to 1 minus a. So a plus epsilon is equal to 1. This is perfectly fine. So from this point on, in other words, perhaps greater than or equal to. So immediately I have, so this is less than 1. Divide n, we have 1 plus n less than 1 over n. So plus 1 on both sides. Plus 1 on both sides. Okay, we immediately multiply by an less than, and this is n plus 1, right? Multiplied by n. Now this time what do? I divide by n plus 1 plus an plus 1, n plus 1 less than n plus 1 gone, an over n. Now to rewrite, I have moved this to the other side, an over n minus n plus 1, an plus 1 greater than this bit. Right, this looks nicer. When n is bigger than this fixed capital N. Okay, so far what I've done, so I've proved by contradiction. It says prove limsup is bigger than or equal to 1. I say how about it's less than 1? What's going to happen? Then I prove that the limsup is actually cannot be negative infinity. Right, since it's less than 1, cannot be positive infinity, cannot be negative infinity either. So it has to be a finite number. Right, then I use the property of limsup, right? That is the biggest limit point. Right? I say, so when small n is big enough, all the members will just is big enough, right? All of them after this one will all live on the left-hand side of this point. That is 1. Right? Then later I just rearranged the equation. Inequality achieved this inequality, right? The same as this one. When n is bigger than the capital N, right? Before capital N, they may be less than that one, but that doesn't matter. Finitely many of them, I don't care, right? So in other words, n equal to capital N, I have this. N equal to n plus 1, I have this. N plus 2, I have this. So in other words, a capital N over capital N minus capital N plus 1. A capital N plus 1 bigger than 1 over capital N plus 1. Also, an plus 1 over n plus 1 minus a capital N plus 2 over capital N plus 2 bigger than 1 over capital N plus 2. Right? Until this one. N can be very, very large, but capital N is fixed. Right? This is a subscript here. So right now I just add them all up, right? Left-hand side, right-hand side. So left-hand side is that you can see this negative term, this positive term. They can just cancel out, right? According to the pattern, this negative term, next positive term. And this positive term with the previous negative term somewhere. So all I have left is this term and this term. right? Capital N, A capital N minus small n plus 1, A small n plus 1, bigger than right-hand side stays capital N plus 1. But 1 over capital N plus 2, all the way, 1 over small n plus 1. Notice, capital N is fixed. Small n can be very, very large. So I move this term to right-hand side, right? So A capital N over capital N is bigger than 1 over capital N plus 1 plus 1 over capital N plus 2. 1 over n plus 1 plus this term to the right hand side becomes positive. So a n plus 1 over n plus 1. Right? But this is right hand side. If I just get rid of this positive term, it's going to be smaller. Right? So still bigger than 1 over capital N plus 1 plus 1 over capital N plus 2. 1 over n plus 1. Right? So I've just loosened the inequality a little bit, but not that small. Right? Because this positive term does not affect. Right? This already tells me something. It's telling this is the what? Harmonic series, right? Harmonic series, we start from 1. Right? We usually start from 1, right? Reciprocals of the whole numbers. Say here's the fixed capital N, right? Continue. Capital N plus 1. Capital N plus 2. Little n plus 1. Right? Now, if I let n approach infinity, small n approaches infinity, capital N stays. Capital N is fixed. Right, what's going to happen to this one? This one, I say it's approaching positive infinity. Why? Because the standard harmonic series, right, already approaching positive infinity. Right, but these are just finitely many terms. I'm starting from here instead, right? So finitely many terms, I don't care. They do not impact the convergence or the divergence of the series. Like I said, this capital N is fixed. 1 million, 2 million, 2 billion, doesn't matter. Right, 1 trillion. It's fixed. So fixed many terms is just a constant, right? No matter how big it is, a finite big number. So this sum still approaches positive infinity. Right, so this no problem. How about the left-hand side? Left-hand side is a fixed number. Right, so right now we have a fixed number that's greater than positive infinity. Like I said, no matter n, capital N could be very big, 1 trillion, one gazillion, but doesn't matter. Still a constant, right? So this already a contradiction. Right? How can a constant be bigger than positive infinity as small n approach infinity, right? Contradiction. So it's all because we've made the false assumption that the lim_sup is less than 1. So this is false assumption, right? Which led to this inequality, which further led to this inequality, which further led to this contradiction, right? So really, it's a false assumption, right? Which means really the lim_sup is really bigger than or equal to 1.